Download this code from codegive.com, link in the description below. OK, let's dive deeper into REST API basics, building upon what we've likely covered in part 1, example HTTP methods, request/response structure, resource identification. This tutorial will focus on practical aspects like request parameters, handling different data formats, JSON, common status codes, and building a very simple API example in Python using Flask. REST API Basics, Part 2, Beyond the Fundamentals. A recap of REST principles. Before we move on, let's briefly reiterate the core principles of REST: representational state transfer. Client server. The client and server operate independently. The client initiates requests, and the server processes them and sends back responses. Stateless. Each request from a client to the server must contain all the information needed to understand and process the request. The server does not maintain any client context between requests. This makes scaling and reliability easier. Cacheable. Responses should be explicitly defined as cacheable or non-cacheable. This allows clients and intermediaries, like proxies, to improve performance by caching responses. Layered system. The client shouldn't need to know if it's communicating directly with the end server or with an intermediary server along the way. This allows for things like load balancers and security layers without affecting the client. Uniform interface. This is the most important principle and includes the following. Resource identification. Resources are identified by URIs, uniform resource identifiers. Resource manipulation through representations. Clients transfer representations of resources, example JSON, XML, HTML, rather than directly accessing the resource itself. Self-descriptive messages. Messages contain enough information to understand how to process them, example content type in the content type header. Hypermedia as the engine of application state, HATIOs. This principle is often misunderstood and sometimes omitted in simpler REST APIs. It means that responses should include links to other related resources or actions, allowing the client to discover the API dynamically. While not always essential, HATIOs promotes better API evolvability and discoverability. 2. Request parameters. Request parameters allow clients to send additional information to the server along with their request. There are two primary ways to pass parameters. Query parameters. Appended to the URI after a character. Multiple parameters are separated by AND. For example, path parameters. Embedded directly within the URI. These are often used to identify specific resources. For example, 3. Data formats, JSON. JSON, JavaScript Object Notation, is the most common data format for REST APIs. It's lightweight, human-readable, and easily parsed by most programming languages. JSON structure. JSON consists of key-value pairs organized into objects, represented by curly braces, and arrays, represented by square brackets. Content type header. The content type header in both requests and responses tells the client and server what data format is being used. For JSON, it should be set to application/JSON. Serialization and deserialization. Serialization. Converting data from a programming language's native data structures, example Python dictionaries, into a JSON string. Deserialization. Converting a JSON string back into a programming language's data structures. 4. HTTP status codes. Status codes are crucial for indicating the outcome of a request. Here's a summary of commonly used codes. *2xx, success. *200 OK, the request was successful. The most common success code. *201 created, a new resource was successfully created, often used with POST requests. The location header should contain the URI of the new resource. *204 no content, the request was successful, but there is no content to return in the response body. Often used with delete or put requests. *3xx, redirection. *301 moved permanently, the resource has been permanently moved to a new URI. The location header specifies the new URI. *302 found, the resource has been temporarily moved. The location header specifies the temporary URI. *4xx, client error. These indicate problems with the client's request. *400 bad request, the request was malformed or invalid. *401 unauthorized, authentication is required, and the client hasn't provided credentials. *403 forbidden, the client is authenticated but does not have permission to access the resource. *404 not found, the resource was not found at the specified URI. *405 method not allowed, the HTTP method, example post, is not allowed for the requested resource. *409 conflict, the request could not be completed due to a conflict with the current state of the resource, example trying to create a resource with an ID that already exists. *422 unprocessable entity, the request was well formed, but could not be processed due to semantic errors, example validation errors. *5xx, server error. These indicate problems on the server side. *500 internal server error, a generic error occurred on the server. *501 not implemented, the server does not support the requested functionality. *503 service unavailable, the server is temporarily unavailable, example due to maintenance or overload. Example REST API in Python with Flask. Let's create a very basic API for managing a list of books. We'll use Flask, a lightweight Python web framework. Prerequisites *1 Python make sure you have Python 3.6 or later installed. 2 Flask install Flask using pip install Flask. Code explanation 1 imports we import Flask, request, and JSON Flask, the Flask class to create our application. Request, to access incoming request data, example json body. JSON to convert Python dictionaries to JSON responses. 2 App initialization app equals Flask, __name___ creates a Flask application instance. 3 In-memory storage *books is a Python list that acts as our database for this example. In a real-world application, you would use a database, example PostgreSQL, MySQL, MongoDB. 4 Find _book, book _ID, helper function *. This function searches the books list for a book with the given ID. 5 Routes and methods *. The @approot, decorator associates a URL path with a Python function. The method's argument specifies which HTTP methods are allowed for that route. *get/books returns a list of all books as JSON. Uses JSON books to convert the Python list of dictionaries into a JSON string with the correct content type. *get/book/int book _ID returns a specific book by ID. *int book _ID is a path parameter. Flask automatically converts the book underscore ID from the URL into an integer. Asterisk uses find underscore book to locate the book. Asterisk returns a 404 not found error if the book doesn't exist. Asterisk posts slash books asterisk creates a new book. Asterisk request.get underscore json retrieves the JSON data from the request body. Asterisk basic validation is performed to ensure that the title and author are provided. Asterisk a new book dictionary is created with a unique ID. Asterisk the book is added to the books list. Asterisk A201 created status code is returned, along with the new book's data. Asterisk put slash book slash int book underscore ID asterisk updates an existing book. Asterisk finds the book by ID. Asterisk retrieves the JSON data from the request body. Asterisk updates the book's title and slash or author if those fields are present in the request. Asterisk returns the updated book. Asterisk delete slash book slash int book underscore ID asterisk deletes a book. Asterisk finds the book by ID. Asterisk removes the book from the books list, using list comprehension for a concise way to filter the list. Asterisk returns a 204 no content status code, indicating success with no response body. 6 if underscore underscore name underscore underscore equals underscore underscore main underscore underscore colon asterisk this ensures that the Flask application is run only when the script is executed directly, not when it's imported as a module. Asterisk app run, debug equals true, starts the Flask development server. Debug equals true enables debugging mode, which provides more helpful error messages and automatically reloads the server when you make changes to the code. Don't use debug equals true in production environments. How to run asterisk. 1. Save the code as a Python file, example appy. 2. Open a terminal and navigate to the directory where you saved the file. 3. Run the application, Python appy. Testing the API asterisk. You can use tools like curl, Postman, or Insomnia to send requests to your API. Here are some examples using curl. Asterisk get all books asterisk. Asterisk get a specific book, ID 1. Asterisk post a new book asterisk. Asterisk put, update, a book, ID 1. Asterisk delete a book, ID 2. 6. Important considerations and best practices. Asterisk error handling asterisk the example API has basic error handling, example checking for required fields. In a real application, you need more robust error handling, including asterisk logging errors to a file or a monitoring system. Asterisk providing informative error messages to the client, but avoid exposing sensitive information. Asterisk using exception handling, try, except blocks, to catch unexpected errors. Asterisk validation asterisk validate the data you receive from the client. This prevents invalid data from being stored in your database and can help protect against security vulnerabilities. Use libraries like Marshmallow or Pedantic for more advanced validation in Python. Asterisk authentication and authorization asterisk protect your API with authentication, verifying the user's identity, and authorization, determining what the user is allowed to do. Common methods include asterisk API keys, asterisk basic authentication, username and password, asterisk OAuth 2.0, for delegated authorization, asterisk JSON web tokens, JWT, asterisk versioning asterisk as your API evolves, use versioning to avoid breaking existing clients. You can use asterisk URI versioning, example /v1/books, /v2/books. Asterisk header versioning, example accept, application/vnd.myappy.v1 plus json. Asterisk documentation. Asterisk document your API clearly using tools like asterisk open API, Swagger, asterisk redoc, asterisk security. Asterisk be aware of common API security vulnerabilities. Asterisk SQL injection. Asterisk cross-site scripting, XSS. Asterisk cross-site request forgery, CSRF. Asterisk authentication and authorization flaws. Asterisk rate limiting. Asterisk protect your API from abuse by implementing rate limiting, limiting the number of requests a client can make within a certain time period. Asterisk testing. Asterisk write automated tests to ensure that your API is working correctly. Use tools like ptest or unitest in Python. Asterisk database integration. Asterisk replace the in-memory storage with a real database, example PostgreSQL, MySQL, MongoDB. Use an ORM, object relational mapper, like SQL Alchemy, for relational databases, or an ODM, object document mapper, like MongoEngine, for MongoDB, to simplify database interactions. Asterisk asynchronous tasks. Asterisk for long-running operations, use asynchronous task queues, example Celery, to prevent your API from blocking. Asterisk API gateways. Asterisk consider using an API gateway to handle routing, authentication, rate limiting, and other cross-cutting concerns. 7. Conclusion. This tutorial has covered some essential aspects of REST API development, including request parameters, data formats, JSON, HTTP status codes, and a simple Python example using Flask. Building a production-ready API involves many more considerations, but this should provide a solid foundation for getting started. Remember to prioritize security, validation, error handling, and documentation as you build your APIs. Keep learning and practicing.